Okay, so we're going to look at three methods of solving quadratics. And I can already see a minor typo there, so sorry about that. And the three methods we're going to look at are square root, factoring, and quadratic formula. So let me put up an example of when you might want to use the square root method to solve. So say I've got x plus 1 squared minus 3 equals 0. The idea being, instead of foiling it out and then combining like terms and then factoring, which we're going to get to factoring in a second, the square root method is nice when it's set up this way, and that you just bring the number over, square root it, and hopefully it'll work out nice and pretty for you. So if I bring the 3 over, I get x plus 1 squared equals 3. And then this is where I'm going to take the square root of both sides. So that's x plus 1. And when I take the square root, I should get a plus or minus of something. And then I can bring over the 1. So negative 1 plus or minus the square root of 3. And then those would be our two answers. Factoring works out nice in that if you can factor it, then it's a nice easy way to set up and solve. Set up equals 0. So if I factor, say, x squared minus x minus 6, I get x minus 3, x plus 2. All right, and then I would take each statement. So x minus 3 equals 0, and x plus 2 equals 0, and solve for x. So x would be 2 and 3. Okay, the last one comes up, and I have seen calculus students know what they're about to do and then just stop doing it because it requires the quadratic formula. It's a very nice, sledgehammer of a process in that it always works, it always gets the job done. So let me give an example here. X squared minus x minus 3 equals 0. So our A would be 1, our B would be negative 1, and our C is negative 3. And so it's negative b, so negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 3, all over 2 times 1. So that's 1 plus or minus the square root of 1 plus 12 over 2. Alright, which is 1 plus or minus the square root of 13 over 2. And that's perfectly fine. There's no, that's not going to simplify down to a nice pretty number. Okay. So those three methods are, for the most part, those will solve most of the quadratic needs you have. And then the rest of the examples I've got worked out are things that might get thrown at you that you should just get in the habit of recognizing. Oh, this is one of my quadratic methods, and I just need to go back over one of those processes. Okay, these first two examples are set up perfectly for the square root process. So in number 1, I'm going to bring the 1 over. So that's 1 equals x minus 4 squared. And then I'm going to take the square root, which is leave us with plus or minus 1 equals x minus 4. And then add 4 to both sides. So 4 plus or minus 1. And so our two answers are going to be 4 plus 1 and 4 minus 1. So that would be 5 and 3. So x equals 3 and 5. Okay. Number 2, again, perfect illustration of the square root process. I'm going to actually bring over the parentheses so I can try to keep things positive and not have to deal with negative square roots if I don't have to. So that'd be x plus a half squared equals 9/4. And then when I take the square root of that, remember we get plus or minus, so plus minus 3/2. And then I want to subtract off the half this time. So negative a half plus or minus 3/2. And so our two solutions would be negative a half plus 3/2 and negative a half, sorry, minus 3/2. Okay, so negative a half plus 3/2, we get, can I bring this over here? We get 2/2 or 1, and negative a half minus 3/2, we get negative 4/2 or negative 2. So our two solutions are negative 2 and 1. Okay. All right, so the next example, we always want to try to factor if possible. So if factoring is going to save the day, then great. So let's see, we'll set up two binomials and see if that works here. So that'll be x and x, and then the minus 3, so it's got to be 3 and 1. And I can think of negative 3 here and positive 1 would factor into that. And if I double check by refoiling, so x times negative 3 would give me negative 3x, and then 1 times x is plus 1x. So negative 3 plus 1 gives me negative 2. So that did work out to be just fine. So x plus 1 equals 0, x minus 3 equals 0. So x would be negative 1 and positive 3. Okay, number 4, same idea. We're going to try factoring first and see if that works. So 15, let's see, two numbers and multiply to 15 add to negative 2. So 5 and 3 have to be utilized. That'd be a negative 5 and a positive 3. So x plus 3 equals 0 and x minus 5 equals 0, which gives us two solutions of negative 3 and positive 5. Okay, so number 5, we're going to try the factoring approach. Let's see if that will work for us. So 6, let's see, we could go 6 and 1, or we could go 2 and 3. Let's try 2 and 3. So 3x and 2x, and obviously 1, well, there's only one way to get that, so that's either 1 and 1. And the last term's positive, but the middle term's negative, so and let's double check that. So if I refoil it, I do get 6x squared. Minus 3x minus 2x gives us the minus 5, so that works. So that gives us 3x minus 1 equals 0, and 2x minus 1 equals 0. So x is a third and a half. Okay. Now number 6, you can try it if you want. There is just no nice way to factor that. So, 8 factors would be 1 and 8 and 2 and 4, and there's just no combination to get a 5 out of that. So factoring is not going to be the best method, which means we're going to go with quadratic formula. So a is 1, b is negative 5, and c is negative 8. So x equals negative b, so negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times negative 8 all over 2 times 1. So the negative 5 give me positive 5 plus or minus, and then we get 25 plus 32 all over 2. 5 plus or minus, and then 25 plus 32 is 57, which is not a nice pretty number. So we can't simplify that square root at all. So those would be our two answers for that. Okay, then we're going to look at things that are quadratic, and the way we solve them is quadratic, even though they might not necessarily start off with quadratic. And you kind of see this off to the side saying use a u sub. This is a concept that comes up in calculus a lot. You will definitely do this u sub process, not 100% of the time with quadratic formula stuff, but you're definitely going to get very familiar with substituting an easier expression in. So when I say use a u sub, we're going to take the middle linear term, which is x squared, and we're going to replace u with x squared, and then rewrite this and see if it jogs our memory and looks something familiar to us. So in terms of u, what is x to the fourth? Well, that would be u squared minus 5u plus 4 equals 0. And that looks definitely like something that we can factor. So that would be u minus 4 and u minus 5. So we get u is 4 and 1. Okay, but we didn't set out this journey to solve for u. We actually wanted x. So if I resubstitute in, I get x squared equals 4 and x squared equals 1. If I take the square root method, I get x is negative 2, positive 2, negative 1, and positive 1. So those would be our four answers there. Okay, number 8. Again, we're looking at the linear term. So I'm going to replace x with the 1/3 with u. So what is x to the 2/3 in terms of 1/3? Well, that's just u squared. So we're looking at u squared minus u minus 6 equals 0. And that's actually one we've just done recently. So that would be u minus 3 and u plus 2. So I get u equals positive 3 and u equals negative 2. And then when I do a substitution in for x, because I really want x, I don't really want the u. I'm not solving for u, I'm solving for x. I get x to the 1/3 equals 3, and x to the 1/3 equals negative 2. This actually comes up sometimes. Looking at the x to the 1/3 equals negative 2, there is no number when I raise it to the 1/3 power. I get, let's see. Okay, backtrack there. So if I cube both sides, I get negative 8 here, and if I cube, so I had to get rid of the cubed root, you cube it, so that would be 27 here. So my two solutions are negative 8 and 27. Okay, so number 9, again, we're going to let the middle term equal our u, so we're going to u equal to x to the 3/4. So what is 3/2 in terms of 3/4? Well, that's just 3/4 to the second power, just u squared. So we get u squared minus 2u plus 1 equals 0. And if I factor that, that's actually one of our perfect squared trinomials. So that fits into u minus 1 squared equals 0, which means u equals 1. And again, I don't want u, I want x. So x to the 3/4 equals 1. So if I raise everything to the 4/3 power, which is what we're doing here, so we're taking that to the 4/3, taking that to the 4/3, either way we get x equals 1. This is our only solution for that. Okay. Number 10, u subs work the same for something like this. Without a u sub, we'd have to FOIL and combine like terms, and we'd just be doing this for a while. But I can set u equal to x minus 5, and then if I convert this all in terms of u, I get u squared minus 4u minus 21 equals 0. And then if I factor that, let's see, that would be u and u, and then I need two things of factors of 21 that add up to negative 4. So if I go negative 7 and plus 3, that'll get the job done. That means u equals negative 3 and positive 7. And again, I wanted x, not u, so that'd be x minus 5 equals negative 3, and x minus 5 equals 7. So if I add 5, let's see, 5 plus negative 3 is 2, and 5 plus 7 is 12. So we get 2 and 12. Okay, 11. 11 just kind of snuck in here. It's not quite a u-sub process because we're just bringing over the middle term. So we get 5x squared minus 11x plus 2 equals 0. And first technique is try factoring if possible. So let's see, 5x and x and 2 and 1. Is that going to work? If we make them both negative, 5x times x is 5x squared. That's a minus 10. That's a minus 1. So yeah, it works. So x is 1/5 and positive 2. Okay. However, number 12 also doesn't fit with our u-sub process in that we're going to make a common denominator out of this, and then somehow the quadratic process is going to show up. So we'll multiply everything. Well, yeah, let's just do that. Everything gets the common. So the common denominator is going to have a 3 in it. It's going to have an x in it. It's going to have an x plus 2. Okay. So this 1 over x, what was it missing? Well, I take the 1, multiply it by the 3, and then multiply it by the x plus 2. And what was the 1 over x plus 2 missing? Well, it's 1 times, and it was missing the 3, and it was missing the x. And then the 1/3 was missing the x and x plus 2. Okay, now at this point we can focus just on the numerator. Because the only way these two fractions are going to equal, obviously the denominator is equal, that means the numerators have to equal each other. So that would be 3 times x plus 2 plus 3x equals x times x plus 2. And then I'm going to distribute and combine like terms. So 3x plus 6 plus 3x equals x squared plus 2x. And now it's starting to look like one of our quadratic things. So if I bring everything over to the right side, I have an x squared. Let's see, I'm bringing 3 and 3, so 6x over with the 2, so that would be minus 4x, and then minus 6. Okay, so we're going to try to factor, and I'll let you kind of stare at that for a second. There's not really any two factors of 6 that are going to add up to -4, so this would be a great problem for the quadratic formula. And so a is 1, b is -4, c is -6. So that would be -4 plus or minus the square root of -4 squared minus 4 times 1 times -6 all over 2 times 1. So that would be, -4. So positive 4 plus or minus 16 plus 24 all over 2. That's 4 plus or minus. And 16 plus 24 is 40 all over 2. Oh, too far. All right, so that's 4 plus or minus. And then 40 we can break up into 10 times 4. Sorry, I just realized you can't see that off the screen. Okay, so 40 is 10 times 4. And I can break, so square root of 40 would be 2 square root of 10 over 2. And then I want to divide everything by 2. So that would be 2 plus or minus the square root of 10, which works out to be our answer. So there you go.